at the bottom. So force exerted by the liquid on the bottom. Bottom, what we get? 3, 4, 8, 7. The force on the bottom. What is to be equal to the pressure at that particular point? Pressure into area A3487. What is the pressure at that point? Rho GH. And what is the area? L into B. This is nothing but equal to rho G HLB. What is HLB? Will become volume. Further, this will become weight of the liquid. So what is the force exerted by the liquid on the bottom? Equal to its weight. So similarly, what is the force exerted by the liquid on the vertical wall? So for that, what we do is we'll assume a strip. Now, why we have to assume a strip? So if you look at the device, so if you look at this particular wall, I'll bring in once again separately. Let's assume two elements, two strips. Let me assume that one. So we know pressure varies with the depth. No? So here, how much of force? dF1. Whatever the pressure at this point will be different. So dF2. Why the area of the strips are same? Will I agree? How much? B dy. Two identical strips, I assume. But the force on the strip 2 will be more than the strip 1. Any reason for that? Because the pressure varies with the depth. So look at the depth of the point y1. So pressure increases with the depth. So therefore dF2 will be greater than dF1. So therefore the different elements will experience a different force. So for that purpose, we are going to assume a small elemental strip first. Then how much of force acting on it? So that will take it dF. Then we'll integrate, we'll get the total force acting on the side wall 1, 2, 3, 4. So what is the formula now? So dF is equal to pressure at location of strip into dA. What is the pressure? Rho Gy. Then what is the area of strip? B into dy. So this will become rho GB y dy. Now what should be the limit? 0 to capital H. Okay, this is the expression for the force. So now we will write this in another form of rho GH into H. Force per unit width. Shall we interpret this? Force per unit width. What is the width? This is a width. This is called like a width. The B is called the width. What it is equal to? Half into rho GH. What is rho GH? Pressure here, we neglect atmosphere. So what is the pressure? Atmospheric pressure will be P naught. So what is the gauge pressure here? Will be 0. What is the gauge pressure here? Will be rho GH. Means if you look at the surface, how do it will get one pressure triangle. Is a very small concept, wide applications. Are you seeing any triangle here? Definitely you're seeing triangle. No? And what is the pressure at a depth H? Rho G capital H. So are you looking at any triangle S? So what is the area of this triangle? Half into base into height. So what is the height? H. What is the base? At base, what is the gauge pressure? Rho GH. So therefore, here of dots, what is the force per unit width acting on the side vertical wall? It should be force per unit width, which is equal to area of pressure triangle. Shall we put it? This will be applicable only when the particular wall, side wall, if it is a rectangular or square. If it is something like a circular disc will come, no, we have to go for alternatives. We have to go for the basic integration like this. Similarly, what is the force on the side wall? 2, 3, 7, 6. Again, you can use the same pressure triangle. So what is this F? What we calculated is force on. Similarly, I want the force on, say like a F2376. This should be equal to half into rho GH into L. Why not H? And this should be the H square will come. Force per unit width. This will be. If you draw the triangle, so only instead of B, what happen? L will be there. Okay, so this will be H. So instead of B, L will be there. This will be the force per unit width. Now for the wall 2376, the width will become L. This height of the wall, this is a base of the wall. The gauge pressure is the base of the wall into this one. So I think directly force per unit width is equal to area of the pressure triangle. It's what you have to remember in exams. You have to proceed further. You cannot spend so much of time fighting here only. So therefore the liquid outline will exert a force on the side wall according to this particular formula. Okay, now we'll take help of the several cases here.